Okay. Zoom. It says find the exact value of sine given that cosine is negative 8/11 and we're quadrant 2. Okay. So I'm going to draw out quadrant 2. It doesn't matter exactly how I draw my triangle, but you're drawing a right triangle with a right angle right there. Okay. The cosine is negative 8/11. So what two parts of the triangle do I know if we know cosine and this is our angle that we're talking about? I know the what and the what. Adjacent is negative 8. What else do I know? Hypotenuse is 11. How can I figure out this side? Because I need that side to figure out my sine. How do I figure out that side, Lindsay King? Exactly. C squared equals A squared plus B squared. So 11 squared equals negative 8 squared plus B squared. So 121 equals 64 plus B squared. If we subtract 64, B squared equals 57? Yeah? Okay, I'll just go with 57 so nobody's confirming that. We'll just say it's square root of 57. And I don't think a perfect square goes into 57. So you'd get square root of 57 over 11. Exact answer using radicals. We good? Okay. All right, this one. Find cosine given that sine is 2/7 and cosine is positive. Well, if sine and cosine are both positive, where am I at? Quadrant 1. Sine is 2/7. Cosine, to figure out this side, again, Pythagorean theorem. 7 squared equals 2 squared plus x squared. 49 equals 4 plus x squared. Subtract 4, 45 equals x squared. Square root, square root. Square root of 9, square root of 5. 3 square root of 5. So the cosine is 3 square root of 5 over 7. Okay, Pythagorean theorem. And then put it adjacent over hypotenuse. All right. Now we're going to talk about reference angles. And we've been kind of using reference angles, especially on section 1.4. We used reference angles without really knowing it. A reference angle is how far are we away from the horizontal axis. And we'll use that angle to figure out what it is. So 285 degrees. 285 degrees. Which of these pictures about shows 285 degrees? A, B, C, or D? Definitely D. Because 270 is right here, and we're a little past 270. So it's not this one, not this one, not this one. It's D. Okay, the reference angle. How far away are we away from the x-axis? Well, this angle right here, or this line right here, is 0 degrees, and it's also 360 degrees. So you take 360 minus 285. 360 minus 285 is 75 degrees. Now they want it in terms of radians. Well, if I know degrees, and I want to change it to radians, I multiply by pi over 180. Okay? So this and this, 15 and 75 is 5. And 15 goes into here. 12 times? So it's 5 pi over 12. How did I do on that? Well, I don't have any complaints, so I must be right. Okay, 4 pi over 3. Which one do you think is 4 pi over 3? And if you're going, that radian junk, I don't get it. Well, if you're really, really stuck with radians, okay, you can change it to degrees. Or what else could you do? Seth just took a sneak peek at his unit circle and found 4 pi over 3. And you can say, well, 4 pi over 3, Mr. Bierschbach, is what, Seth?
be A?
Well, I would certainly think it's A, because how many degrees is it?
240.
It's 240 degrees. Now, it's 240 degrees. What's its reference angle? How many degrees are we away from there? How far is 240 from 180? 60 degrees. How many radians? Well, this is pi radians. This is 4 pi over 3. So you take 4 pi over 3 minus pi. Well, to subtract fractions, we need a common denominator. So take 4 pi over 3 minus 3 pi over 3. And you get 1 pi over 3. And pi over 3, you can look in your unit circle and see that that's the same as 60 degrees. Okay? So this unit circle helps out with a lot of little stuff here. 705 degrees? That's not anywhere close to anything on the unit circle, is it? So what do we have to do? Well, we have to go to the very first lesson we learned at the start of Trig on January, whatever it was, 7th or whatever, 8th, and figure out a coterminal angle with 705. How do we do coterminal angles? Subtract 360. 705 minus 360 is 345? Well, 345 is really close to 360, so it's B. It's only 15 degrees away from 360. 15 degrees, if I want to put 15 degrees in terms of radians, I take 15 times pi over 180. And so it's pi over 12 away. Good? Okay, I'm going to skip over some of these because a lot of these are in your unit circle, but I'm going to stop at number 10 because number 10 gives some people fits, and it shouldn't. It shouldn't, but it does. Okay. The sine of negative 10 pi over 3. Coterminal angles. Okay, let's go coterminal angles with this. Negative 10 pi over 3. How far is it around, all the way around the unit circle one time? In radians. All the way around once is 2 pi. So we're going to add 2 pi to this. 2 pi is the same as 6 pi over 3. So it's negative 10 pi over 3 plus 6 pi over 3 equals 4 pi over 3. Negative 4 pi over 3. And what I'm going to do is I want to make it positive because it's easier to work with positive numbers than negative numbers. So I'm going to add another 6 pi over 3 to that. And we're going to get 2 pi over 3. Then you're going to look at your unit circle and find the sine of 2 pi over 3, which is the y value at 2 pi over 3. If you find the y value of 2 pi over 3, you're going to get square root of 3 over 2. So we basically didn't exactly use a reference angle because we just looked on our unit circle. But our reference angle there officially is pi over 3 because we're only pi over 3 away from the horizontal line. And the sine of pi over 3 is square root of 3 over 2. But, okay, so you got a couple of those. These, when you see these, and these are on your test, I will guarantee you these are on the test. There's a problem like this on your test. You just look on your unit circle and have it help you out. What's the sine of pi over 6? It is 1/2. Cosine of pi over 6? Square root of 3 over 2. And then you go tangent of pi over 6 is y over x. So it's 1/2 over square root of 3 over 2. Got to get rid of the complex fraction by multiplying top and bottom by 2. So it's 1 over square root of 3. Can't leave square root of 3 on the bottom. So you multiply top and bottom by square root of 3 over square root of 3. And you get square root of 3 over 3. Cosecant of pi over 6, flip it upside down. Flip sine upside down, and you get 2. Secant you flip cosine upside down, and you have a square root in the denominator. So you have to multiply top and bottom by square root of 3. So it's 2 square root of 3 over 3. And cotangent, take this and flip it upside down. So it's just square root of 3. Okay, so you'll have a couple of those to do. And yeah. And then we get to these. Okay? Is this a true or false statement? Is the cosine of 300 the same as the negative cosine of 60? Well, what's the cosine of 300? 1/2. What's the cosine of 60? 1/2. So is 1/2 equal to negative 1/2? And the answer is no, that is a false statement. Cosine of 161 and negative 19. 161 has a reference angle, and this is where reference angles comes in, of 19 degrees. It's 19 degrees above the x-axis. Here's 19 degrees here. Now this is positive here because we're going to the right. Over here we're going to the left, so we are negative. Since they're both 19 degrees, their values of cosine are equal, but their signs are opposite. So this would be a true statement because their signs are opposite. So because cosine over here is negative, if we go to the left, cosine is positive if we go to the right. And they're the same values because they're both the same reference angle. Okay. Here, 3 pi over 14 and 11 pi over 14 are both 3 pi over 14 above the x-axis. Okay? Because if you go 11 pi over 14, you're still 3 pi over 14 away from 1 pi. So you're still there. Okay? So, sine is here, sine is here. They are both positive. Here it says, is the positive equal to the negative? And the answer is false. It is not. Okay? They're the same value, numerical value, but they're both positive in this case. Okay? So this is reference angles. This has a reference angle. These have the same reference angle, so they'll have the same numbers. It's just the signs might be different or might be the same depending on what quadrant we're in. Well, here, if they're quadrants 1 and 2, the signs are both positive. It says positive, negative, so that's why it's false. Okay? So 20 problems, I will put that out to you. It will take you a little while. It'll take you the whole class to do this, and maybe then some a little bit. So there you go. On Monday, we'll review and do a practice, or on Tuesday, we'll review and do a practice test. Thursday, test over unit or chapter number 1. And there we go. Thursday test in here.